5G is the latest and the fifth iteration of networking technology and boasts new and improved features that make it stand out amongst its previous generations. It is able to provide transfer speeds of up to 10 gigabits per user, along with a claimed maximum of 1 millisecond of latency. The increase in bandwidth thus allows for an increase in network capacity, allowing for a more interconnected network community among people. 5G is also reliable due to the regulation of data packets and coverage, providing a uniform quality of service. A new feature introduced in 5G is called network slicing, allowing for each device to be connected to its own network by creating virtual networks in the cloud. This allows for a very personalized and specialized network that can be optimized for specific tasks or group of devices. Another feature set that is adopted in 5G are MIMO and beamforming. These features are what make 5G function seamlessly, with MIMO employing full duplex functionality, transmitting and receiving data simultaneously over a single channel, and with beamforming targeting highly populated areas, concurrently reducing interference and maintaining signal integrity. These features combined result in reduced network traffic and latency, overall accomplishing a very efficient network system in both cost and energy. These new technologies can be applied in many areas, a few of which includes autonomous vehicles, implementation of the Internet of Things or IoT, and especially in disaster resistance and management. A 5G network can, for example, provide both content from the internet and prioritized services with quality of service and data security for special applications. And network slicing can do just that, by providing a customized network with just the right connection called a network slice. Each virtual network or network slice comprises of an independent set of logical network functions, with the term logical referring to software. It will be optimized to provide the resources and network topology for the specific service and traffic that will use the network slice. Functions such as speed, capacity, connectivity, and coverage can be customized in each network slice, or shared across different network slices. Traffic in one slice cannot interfere with another slice, and this lowers the risk of introducing and running new services to the network slice. It also supports migration for new technology. In case of a cyber attack, it would only affect one slice and not be able to spread to others. Network slicing is a type of virtual networking architecture in the same family as software-defined networking or SDN and network function virtualization or NFV, which are two closely related networks. SDN allows network slicing to create multiple virtual networks on top of a shared physical infrastructure. SDN manages network traffic flow through application program interfaces or APIs from a centralized controlled plane. SDN in network slicing also determines where the data packet should go, with guidelines baked into the switch which determine where to forward the packet. With that, network administrators are able to provide services throughout the network irrespective of the hardware components. In the occurrence of a natural disaster, network slicing can be applied in a city by constructing a 5G core to connect network slices from different regions with similar characteristics for the communications during mission-critical services. For example, in February 2018, British Telecommunications and Verizon demonstrated autonomous control and management of drones in central London, which were launched from the US by Verizon on a dedicated 5G network slice within British Communications Network. This demonstrates that network slices can be modified, connected, and created without affecting the rest of the network. This saves time, effort, and cost because it eliminates the need to re-engineer the whole network with individual slice changes. In this case, interconnection is achieved by building a 5G core and creating two network slices with similar characteristics. One, a low latency breakout for a British Communications end user, and the other, a Verizon low latency breakout. Since SDN is used in network slicing, the forwarding table is computed and distributed by a logical centralized routing controller. This reduces the processing time to calculate the routing path, allowing the message from the British telecommunications side to be safely transmitted to the Verizon side to control the drones. So in a network slice, resource can be reserved and allocated for disaster aid services and communication, which would mean specialized optimization for different networks or scenarios, like high throughput and low latency, or different TCP protocols for each personalized network, optimized for efficiency. So in the event of a natural disaster, disaster aid services and communications would benefit from network slicing, since a separate and localized network with reserved resources and no interference from other networks will be reliable and less susceptible to failure, since its physical network can be constructed in a less disaster-prone area. The other 5G network feature we'll be looking at is called MIMO, or Multiple Input, Multiple Output, which is a wireless network that allows the transmission and reception of several data signals simultaneously over the same radio channel while using multiple antennas for both transmitting and receiving data. While standard MIMO tend to have 2 to 4 antennas and supporting few devices, massive MIMO is intended for application on a larger scale, usually involving several hundreds of devices, because massive MIMO comprises of about 100 or more antennas within a small area, and these antennas operate on a higher radio frequency band and are utilized to reduce interference and traffic congestion. These frequencies can only travel over a short distance and cannot penetrate solid objects like buildings or even rain. We will also be looking at beamforming, which is the ability to adapt the radiation pattern of the antenna array to a particular scenario. In terms of cellular communication space, beamforming is thought of as a steering lobe of power in a particular direction toward the user. Relative amplitude and phase shifts are applied to each antenna element to allow for the output signals from the antenna array to coherently add together for a particular transmit or receive angle, and destructively cancel each other out for other signals, essentially forming a beam that points straight in the direction of the user. Beamforming and massive MIMO are used in 5G because it's really economic and can be really useful for disaster relief. By directly beaming at the user, 5G will be more energy efficient. Less energy is wasted transmitting signals to unneeded places. In the past decade, the use of drones for civilian applications is exploding. With massive MIMO, we can enable communication with large multi-drone networks that stream big amounts of real-time data to the ground. This can potentially help in search and rescue operations during earthquakes, tsunamis, and other disasters. So in the event of a natural disaster, disaster aid teams will be able to benefit from massive MIMO and beamforming, since they will be able to relay messages much more quicker and be able to target specific areas that will be offline due to damage to the network infrastructure, and it also ensures the coverage for rescuers within the area. So in conclusion, we think that 5G is still a very young technology and requires a lot of research and testing before it can be fully implemented in the coming years. However, it does show promise in the area of disaster management and resistance.